Okay, so for today's lesson, we're trying to do something a little bit different for you. We are looking at today half-life. Okay, and if you're writing anything in your book, if you just write that down, you can write that down as your title. So let's write a few things down on here. So title would be half-life. Okay, and you pop your obviously data and stuff in if you need to. So half-life is the time it takes for half of the unstable nuclei. So that is the nucleus of an atom. That is plural for nucleus. Really important you get that word in there. So half the unstable nuclei in a sample to decay. So obviously we need to be writing that down as a little definition first to make sure that actually makes sense for you. So that is what half-life is. I'm going to try and show you what I mean by that through doing a little practical with you today. So obviously that definition to you right now makes very little sense. But if we imagine we've got lots of atoms, okay, that have nuclei which are unstable. We talked about this before. That might be because they're too heavy, might be because they've got too much energy, it might be because they've got too many neutrons, something like that. And they need to give off radiation to become more stable. And that's why these atoms become, why they decay. So if you've got a really big atom like a uranium-235, so uranium-235, 92, okay, it's really big, it's really heavy. If it gives out an alpha particle, okay, with a mass of 4 and an atomic number of 2, then it is going to become a different element. We're not going into what it's going to be, but it's going to have a mass now of 231 and an atomic number of 90, and it's going to be more stable than it was before. So it's giving out the radiation to become stable, but it's not just one atom on its own. There are thousands, millions of nuclei within a sample of uranium. Okay, and we want to represent that. We want to know how long it takes them to decay, but because it's so random, you don't know which one's going to decay. And to try and show that, I'm going to use some dice, but you're going to try and use some coins, okay? So you're going to do this at home with coins. So what I want you to do now, before I go on to the next bit, is go and find as many coins as you can. So I'm sure most of you have got like a piggy bank or something at home with lots of random little coins in it, and I want you to go and get them, as many as you can find, okay? Obviously, when I say as many as you can find, if you've got like a massive one with thousands in, that's going to take you all day, so don't bother. I'd say about between 50 and 100 is about the number you need, ideally. If you've got a bit less than 50, if you've not got many coins at home, if you don't save them up, fair enough, don't worry about it. And don't worry if you can't do this, obviously, it's not your fault if you can't. Right, so we're going to use these because they are random, okay? Rolling a dice is random. I have coloured in one of these sides of these dice, okay? Or I've not done it, but somebody has, okay? And if I roll that, I've got a random chance of it landing on the coloured in side, okay? Twice in a row. Oh, that's ridiculous. Right. I'm being very lucky today, obviously. There we go. So somehow I got like 7 in a row landing on the coloured inside, but that's obviously very rare, very unlikely that would happen. And if I roll 50 of these together, some of them will land on that side and some of them won't. Just like if I roll all 50 of my 1p coins in here, if I just roll them out, okay, some of them are heads and some of them are not. And what I'm going to say is these represent my unstable atoms, and the ones that are heads decay. And I can take them out of my sample because once they've decayed, they're no longer unstable. So that's what you're going to do. I'm going to show you with the dice, but you're going to do it with the coins. And you're going to take out the ones that are heads. I'm going to take out the ones that are coloured in. Okay. So I'm going to start off with 50 dice. You're going to start off with however many coins you have. Okay. And you're going to have a table, which again you might just need to pause your video just to do this in your books or on paper or something. You're going to have a table that looks like this. Okay, so I'm starting off with, at roll 0, I know I've got 50 dice, okay, and 0 have decayed yet. So roll number 1, I'm going to roll them, count how many decay, and count how many I've then got left. Okay, so I'm going to roll them all out. Some of them might roll off camera. You're just going to have to kind of trust that I'm doing this properly. Okay, so I have got on here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that have decayed. Okay, oh, flipping them around. So I've got 11 nuclei that have decayed. So remember, these little dice are representing my unstable nuclei, and these 11 have now decayed and become stable. So I'm going to put them to one side because they can't decay anymore, so their randomness is now kind of gone. Okay, so I'll just put them all in a line so we can kind of see how many we've got. And just double check count, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that was right. So on roll number 1, 11 of mine decayed, and you do the same thing. You roll all your coins. Okay, I mean, if you've got 50 dice at home, by all means do this, but I doubt you have. So you do it with coins, roll them all. However many decayed, you write down decayed. And now how many have I got left? I've got 39 left, or I must have 39 left. Right. Then my 39 I've got left, I'm going to roll those. Okay, so I'm going to take those all together and I'm going to give them a roll again. Okay, and this time I've got 1, 2, 3, 4, 5, 6, 7, 8 that have decayed. And I'll put those up at the side next to my ones that have already decayed. So again, I'm taking them out of my sample. Okay, and we'll see that because I've got less left, it's less likely that some of them are going to decay. So we've got 1, 2, 3, 4, 5, 6, 7, 8. I think that one I've just hit with my hand. So this time I got 8 decayed. Okay, so I'm going to slide those together. Slide that up at the side. There we go, lovely. So second roll, roll number 2, 8 decayed, and that takes me down to 31. Okay, try again with my 31 remaining. So again, roll those. Okay, and I've got this time 1, 2, 3, 4, 5, 6, 7, 8 again this time. Okay, so normally you're going to have less every time, but sometimes it does just happen that you get a few more than not, like at the start of this video when I rolled 6 coloured insides in one go. There we go. Okay, so again, roll number 3, 8 decayed, 31 take away 8 is 23 if I'm not mistaken. Okay, and then I keep going. I'm going to keep going until I've got none left. I'm not going to record all of it. Okay, I am going to keep going. I'm going to keep doing them until I've got none left though. So this time I've got 1, 2, 3, 4, 5, 6. But I'm just going to do it for you until I get like a decent sort of shape to it. And you're going to do the same thing. So you just keep going until you have 0 dice remaining, or coins remaining, in your case probably, that are unstable. So this time, number 4, 6 decayed, that takes me down to 17. I'll do one more on that I'll record, and then I'll show you the numbers afterwards. So this time I had 1, 2, 3, 4. Okay, but we can already see we're starting to get like a little shape to what is going to end up being like a little graph that we can produce later. And we've got kind of a curve going on here, and if we kept going, we'll probably then get like 3, 2, 1, and we'd start curving this out. So roll number 5, what did I get? 4 decayed, which takes me down to 13. Right, so this is a nice sort of shape that we've got here, and I'll go on now to show you my full set of results, and we'll show you what we should end up with. And then from that, we're going to try and plot a graph. And this shows us how, and we can, from this, then we can work out the half-life. We can work out how long it takes for the number that we started with, the 50, to go down to half of its original number. Okay. Okay, so I continued doing my number of rolling my dice until I got these numbers here shown on my table. So obviously if you are completely unable to do this, if you don't have loads of coins at home or you just don't have time, you feel welcome to use my results that I've got here, and I want you to try and plot yourself a graph using this. So all I'm going to do is go through and I'm going to plot little crosses. This is going to be I know I showed you the little dice at the bottom and that kind of looks like a bar chart, but we want to do this as a line graph because we've got both continuous variables on our bottom and our side axis, so our x and our y axis, because our independent and dependent variable are continuous, so numbers, we are going to plot a line graph. So I'm going to start off by plotting my roll number 0 was at 50. Okay, so I'm going to put a little cross at 50. Roll number 1 was 11, so I'm going to go to, sorry, I'm going to put my number of nuclei left. So number 1 was 39, so I'm going to go to 39 on here, and put a little cross again. Then roll number 2 was 31, so that's going to live there. Roll number 3, 23, so that will be there. 4, 17, it's going to look like that. Number 5, 13, so 10, 11, 12, 13. Number 6 was 9. Number 7 was 6. Number 8 was 4. Number 9, we had 3 left. And then number 10, we had 1 left. And 11, 0. So we can see here the shape that we're getting on our graph. Now I'm going to try my best to draw this in, but it's very difficult with just a mouse. So you can do this by yourself. It should be a lot easier with a pencil if you can do this on a proper piece of paper. But just a nice, neat curve. Ooh, not looking too bad. There we go. A nice, neat curve going down there. So it's curving out. So it starts off steep when we've got lots of nuclei left, and then as more of them decay, we've got less of them left. And that's what happens in real life. Now from this, I can then find my half-life. So if you remember, it was the time it takes for half of the nuclei to decay, or the unstable nuclei to decay. So I started with 50, okay? So to work this out, I need to take what I started with. So I need to take my 50 that I started with, okay? And I need to work out how long it took to get to half the number that we had. So I'm going to do 50 divided by 2 equals 25. So I want to know how long did it take to get to 25 of our dice left. So I'm going to go to 25, and I'm going to go across, and I'm going to go down. And it took 2.5 rolls to get there. So my half-life is 2.5 rolls. Okay, so I want you to have a go at doing the same thing on yours now. Okay, so take your results, plot them in a graph like this. Okay, if you haven't got graph paper, just try your best to do it in your book. None of this has to be perfect. You're at home, you're just doing the best you can do. And I want you to find how long did it take to get to half of yours remaining. So if you started at 100, obviously you need to start at 100, divide that by 2. If you started with, you just happen to have 37 coins, you need to do 37 divided by 2 and go across to how many they are. Now, that's where you need to finish, and that's all you need to send me. So can you send me a picture of your graph with your half-life written on it once you've worked it out? But once you've done, you can just watch this last little bit, because what happens with this, what's good about Half-Life is it's consistent. Because if I then half my 25 to 12.5, which would be about there, and go across and down, look at how many rolls it took to get to half again. So to go from 25 to 12.5, it went from 2.5 to 5, which is another 2.5 rolls. So my half-life has remained constant. So my half-life should always remain constant. It should always remain the same. Okay. So basically, this is why we use half-life, because it is consistent. All right.